While on this subject of arrays and objects, let's recap something that is a reason for headaches even for experienced developers, which is object reference. Let's go back to the code and let me again create a variable called student. Let's assign John, and then let's just log this variable. As you know, if I save, I can see here on the log John. That's because what is going on behind everything is that JavaScript is allocating a space on the memory for this variable. And inside this space, it is including a value there, in this case, John. And for the variable, it works as a pointer, pointing to that value. So whenever I need to retrieve something from that memory, I'm going to use that variable name. Whenever I call student, JavaScript knows it needs to retrieve the value from the memory, and that's what I get here. Okay, no surprises there. And let's make a copy of this variable. So if I create student copy, receive student, and then let's just log this copy. So if I save, as you can see, both student and the copy, both of them are John. What's going on is that whenever I create this copy from one variable to another, the computer is creating a copy of that value on the memory and assigning a new variable to point to that copy. Well, at least that's what we think that is going on, which actually is not. But for now, bear with me. Let's say it is what is going on. So whenever I try to log that information, I can get this exactly same value from the memory. Now let's see what happens if I reassign this value. So let's get student copy and assign Mary, and then let's log this information. So the updated student copy is going to be Mary. Again, no surprises. Student John, copy John. Then I reassign student copy to Mary, and I get the updated value memory. Again, Mary. What is going on in the memory is that whenever I reassign a value, it is using this variable, student copy, knows where it is pointing on the memory, and then it is allocating this new value inside the memory. Everything is stored there, so if I go back to my code and I try to get my original value, so let's go back and log original student. If I save, you can see that my original is John, which makes totally sense because student points to John, while student copy points to Mary. This is the standard behavior that we have, and whenever we are working with objects and arrays, we expect that same behavior to happen. However, it doesn't. Let's go back, let's repeat this example, but with an object. So let me create a student as an object with the properties name John, age 17, and then let's just log student. And if I save, you can see that I have name John, age 17. Again, what is going on is that whenever I create this variable, I am allocating inside the memory a space where I am assigning this object. And I have the properties all stored in the memory, property for name, a property name with John, the property age with 17. Then let's make a copy of this variable. So same as before, student copy, receive student, and then let's just log that information. So if I log student copy and I save, you can see that both student and copy are John, age 17, which makes sense. So far the behavior is what we are expecting. We have created a copy of that variable student. That means that I have created a copy of that same information, and now I have two variables with two different values inside the memory. However, this is not what happens. Let me go back to the code and let's continue our example. So let me make a change and say the student copy dot name is Mary, and let me log the updated copy. If I save, you can see that the updated object now is Mary. Again, that's what I was expecting, but here is the gotcha. If I try to log again my original object student, and if I save that, you can see that my original object is also Mary, which is not. I haven't changed student, I have changed student copy. So what is going on? The issue is right at this point, because whenever I do student copy receives the student, I think that the computer is creating a copy of that information inside of the memory, but it's not. This is not what happens. What really happens is this. The computer will try to save memory. So instead of creating a copy of the exactly same thing, what it's going to do is just point a second variable to the same value inside the memory. So I don't have a copy of that object. What I have is a second pointer pointing to the exactly same object. That means if I go ahead and I try to change studentCopy.name to be Mary, the computer will go to the student copy object it is pointing inside the memory, and it's going to change the property name to be Mary. However, student is still pointing to the exactly same object. This is why whenever we try to retrieve student, we get again this object with the name Mary. But why? Why there is this different behavior from a primitive data and an object? It's not that there is a different behavior. Initially, we assumed that when we did this student copy receive student for this string, we assumed that it was creating a copy inside the memory. But again, it was not. For saving space, it was just pointing a second variable to the exactly same place inside the memory. This way, whenever I try to retrieve both student and student copy, I would get the exactly same value, which I would not even notice that the computer is trying to save some memory doing that. However, the trick is right here whenever I try to reassign a value. So for the string, at some point we did student copy receive Mary. At this point, the computer knows I am changing the assignment, therefore I no longer can point to the same object. I need now to create a second one, create a second value inside the memory, and point to this new one. This is why we got the behavior that we tested before, because the computer was creating a copy whenever it needed to create a copy, and then we saw the change happening exactly the way we were expecting. The same could happen with an object. So right now what is happening here is that I never reassign student copy. Initially, I am assigning student copy to be student. So they are pointing to the exactly same object in the memory. And then I get to this student copy dot name. So I'm not reassigning this variable student copy. I am just changing the property name inside that. And this is why we get this original one being changed as well. If I were, for instance, to reassign this student copy to be Mary, if I save, look what happens. My updated one is going to be Mary. I no longer have an object, it's just a different value, but note that my original one was not changed now, because I'm not pointing anymore to the same one, because I just reassign that object. Therefore, my original one has its own place on the memory, and this student copy now has its own value on the memory as well. However, this is no longer an object, but if I wanted to, I could make student copy receive a new object where I set name Mary, age 17, and if I save now, you can see that everything behaves the way I am expecting. I had the original one, I had the copy, then I updated the copy assigning a new object, which then didn't affect the original one. The original one is still named John, age 17. But again, I'm not making a copy. This copy is not, it's not doing anything for me. I'm just making a copy and then creating the object. This is not useful, but we are going to take care of that later. However, let's take a look also for arrays, because this is the exactly same behavior that we're going to get for arrays. Let's make another example. So let me create an array for fruits. And then let's just log this array on the console. So if I save now, you can see that I have an array with 3 items inside of that. Then I can make a copy of this array, and then I can log this copy and see that this new variable fruits copy has exactly the same content from fruits. Again, I could be thinking that I just did a copy, but it's not a copy. I'm just pointing to the same object inside the memory. So if I go ahead and I try to make a change to the fruits copy, let's say fruits index 1 receives cherry, and I try to log this information, you can see that here on the log I get that the update 1 has apple, cherry, and orange. But if I try to log after that my original one, you can see that the original one was also affected for this change right here. So both fruits and fruits copy are pointing to the same object inside the memory, to the same array. So whenever I make a change to either one of them, the other one is going to be affected because, again, that's the same array inside the memory. So if I get fruits copy or if I get fruits, they are exactly the same. They were changed as well. Again, same as before, that is happening because I'm not reassigning fruits copy. I'm just changing something from there. But if I were to reassign, let's say, fruits copy to be cherry, if I save, you can see that the updated one is going to be cherry. But in this case, I'm no longer affecting the original one because now I really have a copy because I reassigned. So if I go ahead and instead of just a string, I reassign an entire array with the values that I want now, then I would have what I am expecting. Apple, cherry, and orange for this copy, and apple, banana, and orange for the original one. But again, I am using the variables, but I am not really making a copy. It's just something that I need to be aware of, that whenever I am working with object references, if I try to assign one variable to another, I'm going to be pointing to the same place in the memory. I will not make a copy. But what if I really need to make a copy? How can I do that? Then we have spread syntax.